Uh, I said you that I will be doing MCQs under force in 2022, yeah, 2021 and 2022. In 2021, there is no MCQs under force, but in 2022, there are two questions. 2022, there were two questions. 2022, question number 28, related to Newton's laws of motion. Related to Newton's laws of motion. This is a statement question. Read the questions. Read the statements. First one, a ball falling down from a high level, bouncing after touching the ground. Now, a ball is dropped from a height. This is ground level. This is ground level. This ball is coming down. It knocks down here, and then it moves up and reaches the height. This is the statement they have given. Ball coming down, bounces off, and goes up. That is the first statement. What is the second statement? The velocity of a fruit falling from a tree reaching the maximum velocity when it comes close to the ground. This is the ground level. Velocity of a fruit falling from a tree reaching the maximum value when it comes close to the ground. Here we have the object. It is at rest initially. It means that the velocity is zero. It will come under acceleration, gravitational acceleration, and reaches a velocity. Let us take this as v. That is the second statement. What is the third statement? Flinging of passengers forward when brakes are suddenly applied to a running bus. Yeah, we'll check it. And then the fourth statement, changing the direction of a moving football by kicking it. Okay. So what's the question? What is which of the phenomenon agrees most with the Newton's third laws of motion? Newton's third law of motion. Now, what is this Newton's third law? What is this Newton's third law? Every action has an equal and opposite reaction. This is Newton's third law. So, this first statement is related to Newton's third law. What is happening here? This ball is coming down with gravitational acceleration. It is at rest initially. It comes down under gravitational acceleration, hits the surface with a velocity, and bounces off with a velocity. Okay. Let us take this as v1 and v2. Comes down with a velocity, knocks down with a velocity v1, goes up with a velocity v2, and reaches a height. So, how can this ball reaches this height? Here, when this ball make a contact with this ground, this ball is pushing the ground downwards by giving a force downward. And what is this ground is doing? What is the surface is doing? Surface is giving a force in the upward direction. This ball is giving a force to the ground in the downward direction. This ground is giving a force to this object in the upward direction. Therefore, here we can see action and reaction force. What is the action? Ball pushing the ground downwards. What is the reaction? Ground pushing the ball upwards. So it is correct. That should be the answer. Now let us see the second statement. Velocity of a fruit falling from a tree reaching the maximum velocity when it comes close to the ground. So ball is coming and comes under gravitational acceleration and then reaches a velocity. This motion is explaining the Newton's first law. Sorry, Newton's second law. What is this Newton's second law? What is this Newton's second law? Acceleration of a body is directly proportional to the force and inversely proportional to the mass. Acceleration is directly proportional to force and acceleration inversely proportional to mass. This is Newton's second law. So this body is having an force. Now it will be having gravitational acceleration. No? Because of this acceleration, its velocity increases from rest to a velocity, increases from rest to another velocity. Therefore, this is explaining Newton's second law. What is this third statement? Third statement, it's also given in the textbook. This is an example given in the textbook. What is the statement? Flinging of person forward when brakes are suddenly applied to a running bus. Now, let's keep. I will explain to you. Fourth one, changing the direction of moving football by kicking it. That is Newton's second law. That is Newton's second law. I will explain in this third statement. I'm going to clean it. If anything important, take screenshot and note it down. Now, when the bus is moving, when a vehicle is moving with a velocity, the person inside will also have the same velocity. Let us take this vehicle. This vehicle is moving with a velocity 5 meters per second minus 1. This person will also move with that velocity 5 meter per second minus 1. So, now let's take it simply with you. Here an object is moving with a 5 meter per second minus 1. Suddenly a force is acting in this direction. When a force acts in this direction, what will happen? It will decelerate and come to rest. This is what happened, right? That is the same thing happening here. Now, when this vehicle is moving with a velocity 5 meters per second, this vehicle, the driver will apply brakes. When the brakes are applied, what will happen? This vehicle will decelerate. This vehicle will decelerate and come to rest. So, when the vehicle decelerates, what will happen? Its velocity will decrease. Velocity will decrease. Velocity 4 meter per second minus 1, then 3, then 2, then 1, and then finally it will come to rest. This is the motion of the vehicle. Likewise, the person inside the vehicle will also decelerate and will come to rest. Now to decelerate, a force should be act in this backward direction. Now, when an object is moving, now it is 5 meters per second minus 1, it will come to rest now. So, for it to come to rest, it should decelerate. What is mean by deceleration? Acceleration in the backward direction, right? Deceleration means acceleration in the backward direction. In forward direction, it is decelerating. And how can I say in other term? Acceleration in the backward direction. If acceleration in the backward direction, then there should be a force in this direction. So when a force applied in this direction, the body will decelerate and come to rest. Likewise, because the vehicle, when brakes are applied, it will decelerate. A force will be acting in the backward direction. It will decelerate and come to rest. Now, for this person inside the vehicle, a force should be act in the backward direction for him to come to rest now. He is initiated 5 meter per second, and when bus becomes 0, the person should also have velocity 0. Person should also have velocity 0. if his velocity need to decrease from 5 to 0, then then it should be decelerate. If it is been decelerating means there should be acceleration in the backward direction. But if acceleration is in the backward direction, then the force should be act in the backward direction. For this person, how this force is created? By friction. Now, a force will be acting in the person in the backward direction. Friction will create a force. This force will pull this person's leg because this person's leg is in contact with the surface now. This surface will push the person's leg in the backward direction. Will pull the person's leg in the backward direction. So this person try to fall in the forward direction. That's why when when moving vehicle decelerates, person try to fall in the forward direction. This is what is happening. A force is acting in downwards, but there is no any force in the upward direction. Now you can think this in this way. Here we have the person. We have tied a rope to his leg, tied a rope, and then we are pulling it. We have tied a rope to his leg. We are pulling it. Once I pull this person's leg, this person will fall in the forward direction. That is what is happening here. When moving vehicle decelerates, force should be acting in the backward direction. Thus, force is given by this friction. Is given by this friction. This friction will create a force. It will be pulling this person in the backward direction to decelerate him. So at that instance, there is no any force in the top. There is no force in the person's top. Only in the leg force is acting, not in his head or hand. Therefore, he will try to fall forward. This is what is happening. This is explained by Newton's first law. Newton's first law. So what is this Newton's first law? When until an unbalanced force is applied on an object at rest remain at rest, object in motion will move with a uniform velocity. Will move with a uniform velocity. So this is Newton's first law. So answer is answer number 1. I will explain to you this in detail. I don't know whether you have studied all this theory, but no one should have explained this to you. It should be something new to you. Please note it down. So that's it. 2022-28 answer 1. Now 2022 32nd question. It is related to friction. Related to friction. Now there is an object. There is an object. Figure shows how a horizontal force P applied on an object placed on a plane. When the value of P is gradually increased from 0, frictional force acting on the object. How will be the variation of the frictional force? Now, this person is giving a force to this object, giving a force P to this object. He is gradually increasing this force. If he is gradually increasing this force, what will happen to the frictional force acting on this object? That's the question. So, yeah, let us take the static friction. And this is the surface. So let us take the static friction on this surface. Now here a force is given in the forward direction. Let us take the static friction here is Mm, 7 Newton. Let us take says 8 Newton. 8 Newton is a static frictional force. Now, I will put a table. Wait. This is the force P that I am giving, and this is the friction. When I apply 1 Newton, now this is the force. When I apply 1 Newton, will this box move in the forward direction? No, because 8 Newton is greater than 1 Newton. Therefore, this object will not move. It will stay at rest. If I give 2 Newton, also the object will not move. If I give 3 Newton, 4 Newton, 5 Newton, 6 Newton, let us take 6 Newton friction. 6 Newton. So if I have 1, 2, 3, 4, 5, all these forces are less than 6 Newton. Therefore, the object will not move in the forward direction. Object will remain at rest. If object remain at rest, what is the friction acting? Static friction. The given force is less than the static friction. Therefore, this object will not move. When we apply 6 Newton also, the object will not move. Object will remain at rest. But once I given a force greater than 6 Newton, when I apply 7 Newton, what will happen? This object, when I apply 7 Newton, 6 Newton is less than 7 Newton. So there will be a resultant force. There will be a resultant force. What's the resultant force? 7 minus 6, 1 Newton. 1 Newton will be acting in the forward direction. So when 6 Newton is applied, object will not move. What is the friction acting? Static friction will be acting. So and at that 6 Newton only, the limiting friction will be acting. The maximum static friction is the limiting friction. When 6 Newton is given, the object will just starts to move. It will not move. It will be at rest. It is something middle between the movement and being at rest. So when we give 6 Newton, object will just starts to move. Once we apply 7 Newton, object will be moving. When the object moves, what is the friction acting? Initially, it was static friction. And when the friction becomes 6 Newton, what will happen? The limiting friction will be acting on the body. Limiting friction will be acting on the body. After that, once the force given is further increased, once I apply 7 Newton, what is the friction acting? Once here, when I applied force is when P is equal to 6 Newton, applied friction is limiting friction. The friction acting on this body is limiting friction. When P is equal to 7 Newton, there will be a friction acting. That friction is dynamic friction. Why dynamic friction? Because when 7 Newton given, the object will start to move in the forward direction with a resultant force of 1 Newton, or with an unbalanced force of 1 Newton, object will start to move, dynamic friction will be acting. So you know the diagram here, the diagram for friction versus force. Force is here, it's P, right? The force here is P. Here the force is P. So when I apply 1 Newton, 2 Newton, likewise 1 Newton, 2 Newton, here the friction is 1. Here friction is 2. Here friction is 3. Likewise it will increase, no? Likewise it will increase. So when I give 6 Newton, the maximum force will be acting. That is the limiting friction will be acting. And once I apply 7 Newton, what will happen? Once I apply 7 Newton, dynamic friction will be acting. Always remember, dynamic friction is less than limiting friction. Dynamic friction always less than limiting friction. So when I apply 7 Newton, what will happen initially? 1, 2, 3, 4, 5, up to 5, the friction will be limiting friction. Once I apply 6 Newton, sorry, 1, 2, 3, 4, 5, up to 5 Newton, static friction will be acting. At 6 Newton, limiting friction will be acting. At 7 Newton, the friction will slightly drop. Friction will slightly drop, and then it will remain the same. Here, dynamic friction will be acting. Dynamic friction will be acting. Always, dynamic friction is less than limiting friction. So here, dynamic friction will be acting here. Okay. So what is the, now we'll read the statements. Takes a constant value continuously from the beginning. That's wrong. Here, when I apply 1 Newton, static friction is 1 Newton. When I apply 2 Newton, static friction 2 Newton. When I apply 3 Newton, static friction 3 Newton. When I apply 6 Newton, limiting friction is 6 Newton. When I apply 7 Newton, friction slightly drop and remain constant. After that, dynamic friction will remain constant. There will be no change. So at dynamic friction only will remain constant. Here it said take when the P is increasing, it always takes the friction takes a constant value continuously from the beginning. When not from the beginning, it doesn't have a constant value. It's wrong. Increases gradually from 0 to a maximum value and then decreases gradually. It's also wrong. The first part of the statement is correct. The friction will increase gradually. It's correct. But when 7 Newton is applied, the friction suddenly drops. Friction suddenly drops. It does not gradually drops. It does not drop gradually like this, a slope. It does not drop like a slope. It suddenly drops. Therefore, it doesn't drop gradually. It drops suddenly. Therefore, the second statement is wrong. Increases gradually from 0 to a maximum value and then decreases gradually. That's the third statement, right? The third statement is wrong. Second statement, see, increases gradually from 0 to a maximum value. Yeah, increases gradually from 0 to a maximum value. That's correct. And yeah, we'll see. Will you right? That seems like correct. Increases gradually from 0 to a maximum value, then decreases slightly and takes a constant value. That is the most accurate answer. The second statement, what he said, only half of the answer is said there. It increases gradually. That's all. After that, they have finished it. The statement is over. But you see the fourth one, it has been completely explained. Gradually increase, slightly drop, and remain constant. Therefore, answer is fourth. Answer fourth. I hope you got a good explanation. Please take the screenshot and write the review. Please write the review, if not, you will forget it. I'm going to clean it. That's it. MCQs are over. Now we will do part 2 questions. Other MCQs are done. Last 10 years, MCQs under Unit 4, 5, and 9 finished. There are 4 or 5 part 2 questions are there. Now we will do all those.